Okay, this is the video for section 1.1 on functions. So first thing we're going to talk about is just reviewing real numbers and the subsets that are included with real numbers. So first off, we have rational numbers, which we use the symbol Q. Rational numbers include anything that can be written as a fraction, so a decimal, a fraction, positives and negatives. Irrational numbers are numbers that cannot be written as a fraction. So, for example, the square root of 3, the square root of 2, pi, anything that cannot be written as a fraction is irrational. Part of the rational numbers, there are three more subsets. First are the integers with the letter Z. Integers can be positive and negative. They are not fractions. Whole numbers, W, can start with 0 and then can be positive integers. And then the natural numbers, not including 0, but positive integers. So sets of numbers can be used, described in set builder notation and interval notation. First we're going to look at set builder notation. Set builder notation looks like this, and if I was to read this, I would say that x such that negative 3 is less than or equal to x, less than or equal to 16, and x is an element of the integers. So I know a range of numbers that are included from negative 3 to 16, and that includes negative 3 and 16, and those are all part of the integer set. So if I have this example, the numbers 2, 3, 4, 5, 6, and 7, and I'm supposed to write those in set builder notation, we're talking about numbers that are natural numbers and equal to 2, less than or equal to 7. So if I was going to write that in set builder notation, I would say that x such that 2 is less than or equal to x, less than or equal to 7, and x is an element of the natural numbers. The next example says describe x greater than negative 17. So it doesn't give us specifics about what numbers can be included in this. It just says that it has to be greater than negative 17, not equal to negative 17. So that includes all kinds of numbers. Rational numbers, irrational numbers, whole numbers, integers, natural numbers, all those can be included in that. So all real numbers that are greater than negative 17. So I would say x such that x is greater than negative 17 and x is an element of the real numbers. Next it says describe all multiples of 7 using set builder notation. So a multiple of 7 means something times 7. So I would say x such that x equals 7 times n, where n is an element of the integers. I could multiply anything times 7 and it would still be a multiple of 7. Okay, next we're going to look at interval notation, which we will use most often in pre-cal, and we're going to use inequalities to describe those subsets. We're going to use brackets and parentheses to help us describe those sets. So this is a big chart that has a lot of information, but what I always remember when we're talking about interval notation is that anytime you see a bracket, that's when it can equal that value. A bracket will always have to do with equaling something. A parentheses is when it's not equal to, or if we're including positive or negative infinity. Okay, so a bracket is when it actually equals that number. Parenthesis, it doesn't equal it, it goes right up to it, or that includes positive and negative infinity. So in this inequality, you have negative 2 is less than or equal to x, less than or equal to 12. So I'm including numbers between negative 2 and 12 and actually equaling negative 2 and 12. So I'm going to be using a bracket, negative 2, comma, 12, close bracket. Real simple. Next one says x is greater than negative 4. So not equaling negative 4, but anything that is bigger than negative 4. So since it's not equaling -4, I'm going to use an open parenthesis, -4, and then it could be anything bigger than that all the way to positive infinity, and I would use a closed parenthesis on that as well. So from -4 to positive infinity, both in parentheses. So that's the same example as we did 2 steps ago. I'm going to skip that one. Okay, so a relation is a rule that relates two quantities. Such a rule pairs the elements in a set A with elements in a set B. The set of all inputs is the domain of the relation, and the set B contains all outputs is the range. So usually when we're talking about domain and range, we say that the x's are part of the domain. That's what you put into a function. The y's are the result, and that's what you get out of the function. That is part of the range. Okay? So here's just a few different ways that we can represent relations. Okay, so verbally we could write a sentence that describes how the inputs and outputs are related. Numerically, we could write a list of numbers or create a table of numbers. Graphically, we could plot some points. And then algebraically, we could have an equation that relates those numbers as well. So a function is a special type of relation. And this says that a function f from set A to set B is a relation that assigns each element x in set A exactly one element y in set B. So basically what this means is that in order for a relation to be a function, the x's cannot repeat. There's only one x value that is assigned to one y value. Now y values can repeat, that's okay, but x's themselves cannot repeat. Okay, this also says that an element in the domain cannot be associated with two different elements in the range. Okay, one way that we do that visually is we use the vertical line test. So if I draw a vertical line anywhere on my graph, it can only touch that graph one place through the vertical line. If that line at any place would touch 2 times, then it would not be a function. So some examples that are not functions would be a circle, an ellipse, a parabola that opened left or right. Okay, those would not be functions. Okay, so function notation just replaces f of x with y that we're used to seeing. So just remember that y and f of x can be used interchangeably. In the middle it says because it can represent any value in the function's domain, x is the independent variable. A value in the range is the dependent variable. Okay, so let's identify whether this is a function or not. So it says the input value is the height of a student in inches, and the output value is the number of books that that person owns. So if I was to poll everyone in the room and find out everyone's height and then how many books they own, chances are that there are going to be people in the room that have the same height, okay? And there may be people in the room that own the same number of books. There's not necessarily any relationship between how tall you are and how many books you own. That doesn't mean anything. But just looking at the x part of this relationship, the height, we could have several people that have the same height and different numbers of books or the same numbers of books. That doesn't really matter. But since several people would have the same height, that's repeating the x value, which makes this not a function. Okay? Next up, I'm looking at a table of values. You can see in this table that I have 1, 1, 4, 4. Those x values again are repeating, and so this is not a function. Okay, if we're looking graphically to determine if it's a function or not, remember we're going to use that vertical line test. And if I draw vertical lines anywhere on this parabola, I can see, actually using the grid that's already up there, that those vertical lines only touch one place on the graph throughout. So this one would represent a function. Now, if we were doing a parabola that opened left or right, like I talked about earlier, then that would fail the vertical line test, and so it would not be a function. Okay, when we're talking about the domain of a function, we're talking about all of the possible x values that could be for that function. Okay, so sometimes we have to determine what are all of the possible x values that we could plug into this situation, and that's called the implied domain. Okay, and then last thing, a function that is defined using two or more equations for different intervals is called a piecewise function. And we'll talk more about a piecewise function later, but it looks like pieces of several functions put together. It's probably broken up into different chunks.